Imagine you're deep into a massive multiplayer game, and you finally have enough gold to buy a high-tier sword. You walk up to the merchant, click Purchase, and the transaction starts. Behind the scenes, the game code begins executing this request step by step. First, it deducts the gold from your inventory, but right before it can generate the sword and place it in your hands, the server hits a random error. Look at this flowchart mapping the transaction. The code successfully completes the deduct gold step, but it snaps right at spawn item. The execution just stops, exactly halfway through the process. You are now stuck in a corrupted state. Your gold is permanently gone, and you have no sword to show for it. For developers running live service economies, untangling thousands of these half-finished, broken transactions is an absolute nightmare.
To prevent these broken states, traditional programming languages like C++ or visual scripting tools like Blueprints rely on manual error handling. Developers have to write extensive try-catch blocks and check for null values at every single step of the exchange. The negative byproduct is that even a simple exchange of items requires a massive, fragile web of defensive code, just to anticipate every possible error. Maintaining that logic becomes increasingly difficult as the project grows. Epic Games is currently building Unreal Engine 6, an engine designed to manage thousands of players and objects interacting across distributed server clusters. And CEO Tim Sweeney knew that manual error handling could not survive that level of scale. When you multiply that fragile defensive code by millions of concurrent interactions, the model mathematically breaks down. To fix it, Epic had to invent an entirely new programming language called Verse. Verse moves away from traditional programming constructs like nulls and crash-inducing exceptions. These concepts are simply not part of the language's vocabulary. Instead, it relies on failable expressions. In Verse, a piece of code is only allowed to do one of two things. It either succeeds and returns a value, or it fails and returns nothing. This diagram shows Verse handling an out-of-bounds array error. The language forces you to wrap risky actions inside a failure context, like an if block. Instead of crashing, the error is safely captured. The code defaults to an else condition, continuing along a predetermined safety path. By making failure a strict language-level rule, unchecked errors are eliminated. Developers are forced to build safety nets into the logic before the code is compiled. These failure contexts provide the mechanical hooks for a much more powerful back-end architecture, software transactional memory, or STM. Using the transacts effect, the engine executes the sword-buying code speculatively, inside an isolated bubble separated from the game database. If an error occurs, the failure context triggers a rollback. The bubble pops and the gold reverts to its original state. Compared to the messy defensive code on the left, Verse provides a clean, automatic rollback on the right. Software transactional memory treats complex interactions as atomic transactions. Either every step succeeds and the changes are committed, or the entire operation cleanly disappears. This architecture is the core of Epic's long-term vision for Unreal Engine 6 and its new scene graph framework. Platforms like Fortnite Creative already have thousands of creators deploying custom logic to live servers every day. In this environment, stability isn't just a preference, it's an operational requirement. As Epic relied on traditional programming models, a single mistake by one amateur coder could potentially corrupt the shared server state for every other player on that instance. To host a massive open simulation, Epic had to mandate a language that makes it mathematically impossible for a local script error to crash the global state. Verse moves the developer's focus away from debugging low-level crashes and toward designing high-level game logic. It represents a shift in thinking. Failure is no longer treated as a catastrophic system event. It is a predictable, safe tool for controlling how a program behaves. As persistent digital worlds grow to support more users and more complex data, this level of transactional consistency becomes the only way to ensure the simulation remains stable. By hard-coding the anticipation of failure directly into the language, Epic Games has engineered a foundation where the simulation remains consistent, regardless of the errors thrown at it.